Alright, solving absolute value inequalities is going to be very similar to solving absolute value equations and linear inequalities. So the absolute value equations, if you recall, once we isolate the absolute value, we'll break up the equations into two linear equations, and the inequality then from there will work just like the regular linear inequalities. So let's look at an example. So the absolute value of x is greater than or equal to 2. So if you recall that the absolute value means the distance away from 0. So let's look at what this is saying here. Here's 0. And it says that I took the absolute value of something, and let's just start with the equal to part. It's equal to 2. So definitely if we took the absolute value of 2, we would get 2. But what else could we take the absolute value of that would give us positive 2? The answer is negative 2. So definitely both of these are in our solution, but what else? So this says we took the absolute value of some number and it gave us a value that was greater than 2. So what could I take the absolute value of that would give me something greater than 2? Well, I could take the absolute value of 3, and that would give me 3, and that's definitely greater than 2. Or 4, or 5, or 6, 7, anything greater than 2, the absolute value would give me something greater than 2. But likewise on the other side, what if I took the absolute value of negative 3? Well, since the absolute value of a number is its distance away from 0, the absolute value of negative 3 is positive 3. So I could have taken the absolute value of negative 3, and that would give me positive 3, which is definitely greater than 2. So same thing with negative 4, negative 5, so on and so forth. So I could have taken the absolute value of anything greater than or equal to positive 2 or less than or equal to negative 2. So what does that mean about how my absolute value inequality breaks apart? Well, the absolute value of x greater than or equal to 2 would then break apart into x could be greater than or equal to 2, or x could be less than or equal to negative 2. So it's going to break apart the same way the absolute value equations did as far as one positive, one negative, but we also have to flip the inequality symbol. So we'll have one that looks exactly like the original equation or inequality just without the absolute value, and one where the inequality symbol and the number are both the opposite. So we were greater than, now we're less than, we were positive, and now we're negative. Now x is now isolated, so we don't have any more work to do with this one. We already have the number line. Let's go ahead and write this in interval notation. So I know it's greater than or equal to positive 2 and less than or equal to negative 2. So we would have negative infinity to negative 2, bracket, because we have the equal to sign, union 2 to infinity. So let's do one a little more beefed up. So let's say we have negative 2 times the absolute value of x plus 5 minus 3 is greater than negative 5. And I want to solve this absolute value inequality. So since it is an inequality, if I multiply or divide by a negative, the rule still applies that I flip the inequality symbol. But the first thing that I need to do is isolate the absolute value. It doesn't matter what's inside. I need to get everything that's outside away from the absolute value before I can split it apart. So I have a negative 2 and a positive 3 that I need to get rid of. Starting with what is being added or subtracted. So this 3 is obviously being subtracted, so I'll add it to both sides. I get negative 2 times the absolute value of x plus 5 is greater than negative 2. And I still have the negative 2 on the outside. It's being multiplied, so I will divide both sides by negative 2. Negative 2, negative 2. Give me 1, so I get 1 times the absolute value of x plus 5, which we can just write as the absolute value of x plus 5. I divided by a negative, so I do need to flip my inequality symbol, and negative 2 divided by negative 2 is a positive 1. So now that we have the absolute value isolated, we took the absolute value of some number, gave me something less than 1. So that means that what we took the absolute value of, in this case x plus 5, has to be less than 1, or x plus 5 has to be greater than negative 1. See how those two split apart? And now we broke it apart into two linear inequalities that we can now solve. subtract 5 from both sides. I get that x is less than -4 and x is greater than -6. And so we can do this on a number line, see how many inequalities we'll actually have. Here is -6, here is -4. Neither of them are equal to, so I know I have open circles, and now let's see which way we're supposed to shade. From -4, I'll end up shading to the left, and from -6, I'll shade to the right. And we see if I shade to the left from -4 and to the right from -6, they will meet up here in the middle. So I'll only have one shaded area, which means one interval from -6 to -4, both open circles, so I get parentheses. And there's my solution to this absolute value inequality. One thing that we do have to be mindful of, since this is absolute value, remember that every time we take the absolute value, since it is a measurement of distance, we will always get a positive number. So things to watch out for. Let's look at two different situations real quick. So let's say we've isolated the absolute value in an inequality, and we come up with a negative on the other side. Now, when we were solving inequality absolute value equations, that was automatically no solution, because we couldn't have take the absolute value of a number and get a negative number, so that was a no-go. But with the inequalities, we kind of got to look at exactly what this is saying. Look at this first situation. I take the absolute value of a number, and I get something greater than a negative. What numbers can you take the absolute value of that will give you something greater than -3? Well, since when we take the absolute value of a number, it's always positive, then any number we take the absolute value of would give me something greater than -3. So in this situation, we would have all real numbers, all reals. Lots of different ways we could see this. This is just the symbol for all the real numbers. We could have all reals, just this symbol right here, or we could write in an interval notation, which would be -infinity to +infinity. We could take the absolute value of any number, and this would be true. Now the second situation, we take the absolute value of some number, and it's less than -3. So what types of numbers are less than -3? Well, more negative numbers, -4, -5, -6, so on and so forth. But we know when we take the absolute value of a number, we should get something positive. So there's no number we could take the absolute value of that would give me something negative. So in this situation where we have the absolute value isolated and it's less than a negative number, this would be no solution.